limit of x tends to 0 root of 3 plus x minus root of 3 minus x upon x equals a 2 by root 3 1 upon 2 root 3 b 1 by root 3 c 2 by root 3 and d root 3. So first we have to take it in 0 by 0 form. So therefore from the question we get limit of x tends to 0 root of 3 plus x minus root of 3 minus x, and we multiply and divide it by its conjugate, root of 3 plus x plus root of 3 minus x upon x into root of 3 plus x plus root of 3 minus x. So from this we get limit of x tends to 0, open the brackets, we get 2 by root of 3 plus x plus root of 3 minus x. Applying the limit of x tends to 0, we get 2 by root 3 into root 3. The plus sign, 2 by root 3 plus root 3, which gives us 2 by 2 root 3, which is 1 by root 3. Option B. Limit of x tends to 0 sin 7x into sin 11x by 5x square equals a 89 by 5, b 56 by 3, c 77 by 5 or d 65 by 3. So first we have limit of x tends to 0 sin 7x into sin 11x upon 5x square. That is nothing but we could write it as 1 by 5 limit of x tends to 0 and sin 7x by x and limit of x tends to 0 sin 11x by x. That is nothing but 1 by 5 limit of x tends to 0, here is 7 and here is 11. That is 177 by 5, which is option C. Limit of x tends to infinity 2x minus 3 into 3x minus 4 upon 4x minus 5 into 5x minus 6 equals a0, b 1 by 10, c 1 by 5 or d 3 by 10. So first we could arrange the numerator as taking x common, we get x into 2 minus 3x, and here also we take x common, 3 minus 4x, 4 by x upon x into 4 minus 5 by x into x into 5 minus 6 by x. Now we apply the limit of x tends to infinity and the terms with 1 by x turns to 0. So we are left with 2 into 3 upon 4 into 5. That is 6 by 20, which is 3 by 10. Option D. Limit of x tends to 9, x raised to 3 by 2 minus 27 upon x minus 9 equals a 3 by 2, b 9 by 2, c 2 by 3 or d 1 by 3. So we have we could write this as limit of x tends to 9 root x raised to 3 minus 3 cube upon root of x plus 3 into root of x minus 3. We could write this as limit of x tends to 9 root of x minus 3 into x plus 3 root x plus 9 upon root x plus 3 and root x minus 3. These two terms cancel out. We have just simply expanded the numerator and we apply the limit of x tends to 9 and replace the value of x by 9. That gives us 9 plus 3 root 9 plus 9 upon root of 9 plus 3. That gives us 27 by 6, which is 9 by 2, which is option B. Limit of x tends to 2 x raised to 6 minus 24 x minus 16 upon x cube plus 2x minus 12 equals a 14, b 17, c 12 or d 19. So what we do is first we divide the term numerator with synthetic division. That gives us x raised to 6 minus 24 x minus 16 equals x minus 2 into x raised to 5 plus 2x raised to 4 plus 4x cube plus 8x square plus 16x plus 8. So we write this whole term in the numerator now, giving us limit of x tends to 2 x minus 2 into x raised to 5 plus 4x raised to 4 2x raised to 4 plus 4x cube plus 8x square plus 16x plus 8 upon x minus 2 into x square plus 2x plus 6. Now these two terms get cancelled out and we apply the limit of x tends to 2 on these terms and substitute the value of 2 in the place of x and calculate the values for the following. That gives us the summation of 168 upon 14, which is 12, option C. The value of limit x tends to 1 x plus x square plus till x raised to n minus n is a n, b n plus 1 by 2, c n into n plus 1 by 2 or d n into n minus 1 by 2. So first we could write this in the form, the numerator can be written as x minus 1 plus x square minus 1 square plus x cube minus 1 cube and so on till x raised to n minus n upon, as given here, x minus 1. So now you can see these two terms, they are similar and we'll try to bring them or cancel them out. So we'll take each individual numerator with this denominator, giving us limit of x tends to 1 x minus 1 upon x minus 1 plus x square minus 1 square upon x minus 1 and so on till x raised to n minus n upon x minus 1. Now we can apply the limit of x tends to 1 and you can see wherever 1 is replaced will turn to 1 minus 1 upon 1 minus 1, that is 0 terms. So therefore we are left with, we get 1 plus 2 into, we take x square into x plus 1 out, 1 raised to 2 minus 1 plus 3 into 1 raised to 3 minus 1 and so on up till n into 1 raised to n minus 1. So that is equal to 1 plus 2 plus 3 plus so and so till n, and as you know summation of n numbers is n into n plus 1 by 2, which is C. Limit of x tends to 2 x square minus 4 upon x root x minus 2 root 2 equals a 4 by 3 root 3, b 4 by 2 root 3, c 4 by 3 root 2 or d 4 by 2 root 2. So first we have this equation in 0 by 0 form. So what we'll try to do is now expand the numerator and divider. We take the numerator first, x tends to 2, and we'll have x square minus 4 square to be written as x square minus 4 square into what we could do is take the conjugate of the denominator. Yeah, do that. Plus 2 root 2 upon x root x minus 2 root 2 into x root x plus 2 root 2. Now we'll multiply these terms, giving us limit of x tends to 2, x square minus 4 x root x plus 2 root 2 upon, this is in the form of a square minus b square. Then x tends to 2, x minus, sorry, this is a square, x minus x plus 2 upon x root x plus 2 root 2 upon x square plus 2x plus 4. That gives us, on applying the limit of x tends to 2, limit of x tends to 2, x square minus 4 upon x root x minus 2 root 2 equals a 4 by 3 root 3, b 4 by 2 root 3, c 4 by 3 root 2, or d 4 by 2 root 2. So now we know this is in 0 by 0 form, so therefore we could write limit of x tends to 2, and we take cross multiply, multiply and divide by the conjugate of the denominator, giving us x square minus 4 into x root x plus 2 root 2 upon x root x minus 2 root 2 into x root x plus 2 root 2. So that gives us, we can write limit of x tends to 2, x square minus 4 into x root x plus 2 root 2 upon x cube minus 2 cube, which equals limit of x plus 2 into x root x plus 2 root 2 upon x square plus 2x plus 4. Now we can apply the limit of x tends to 2, that gives us 2 plus 2 into 2 root 2 plus 2 root 2 upon 2 square plus 4 plus 4, that is nothing but 4 by 3 root 2, which is option C. Limit of x tends to 0, root of a plus x minus root of a minus x upon x root of a into a plus x equals a 1 by root a, b 1 by b, c root a, or d 1 by a root a. So first what we do is we multiply and divide it by the conjugate. So we have limit of x tends to 0, root of a plus x minus root of a minus x upon x root of a into a plus x from the denominator into now the conjugate root of a plus x plus root of a minus x and root of a plus x plus root of a minus x. When we open this bracket, we get limit of x tends to 0, 2 by root of a into a plus x into root of a plus x plus root of a minus x. That when we apply the limit x tends to 0 on this, we'll get 2 by root of a into a upon into root of a into a. That is there's a plus here, root a plus root a. That gives us 1 by a root a, which is option D. The value of limit x tends to 2 root of 1 plus root of 2 plus x minus root 3 upon x minus 2 equals a 1 by 8 root 3, b 1 by root 3, c 8 root 3, or d only root 3. So first we could write the numerator as limit of x tends to 2 1 plus root of 2 plus x minus 3 x minus 2 into root of 1 plus 2 root of x plus root 3. This we get by multiplying and dividing by the conjugate of the numerator. So that gives us root of 2 plus x minus 2 upon we have x minus 2 into root of 1 plus root of 2 plus x plus root 3. Now that equals, we could take it as 1 upon the limit of x tends to 2 root of 1 plus 2 root of 2 plus x plus root 3 into 2 plus x plus 2 equals, when we take the limit of x tends to 2, we get 1 by 2 root 3 into 1 by 4, which is equal to 1 by 8 root 3, option A. The value of limit x tends to 2a of root of x minus 2a plus root x minus root of 2a upon root of x square minus 4a square is a 1 by root 2 1 by root a, b 1 by 2 root a, c root a by 2, or d 2 by 2 root a. So therefore we could write the numerator as limit of x tends to 2a root of x minus 2a plus x minus 2a upon root x plus root of 2a upon the denominator in its expanded form x minus 2a the whole root upon into root of x plus 2a. Now that gives us limit of x tends to 2a 1 upon root of x plus 2a plus root of x minus 2a upon root of x plus 2a into root of root x plus root of 2a. Now once we get this, we can apply the limit of x tends to 2a. That gives us 1 by root 4a, which is 1 by 2a. 1 by 2 root a, which is option B. If limit of x tends to pi by 4, 4 root 2 minus cos x plus sin x raised to 5 upon 1 minus sin 2x is A 5 by root 2, B 3 root 2, C root 2, D 5 root 2 by 2. So first what we do is we can rearrange the terms in the numerator and write it as limit of x tends to pi by 4 cos x plus sin x square raised to 5 by 2 minus 2 raised to 5 by 2 upon 1 minus sin 2x sin 2x minus 2, which gives us limit of x tends to pi by 4 cos x. We replace cos x in the numerator with 1 plus sin x raised to 5 by 2 minus 2 raised to 5 by 2 upon, and the same denominator 1 minus sin 2x minus 2. We can replace x by y and pi by 4 by 2. That gives us limit of y tends to 2 y raised to 5 by 2 minus 2 raised to 5 by 2 upon y minus 2, which is 5 by 2 into 2 raised to 5 by 2 minus 1, which is 5 root 2, which is option A. Limit of x tends to pi by 6, 3 sin x minus root 3 cos x upon 6x minus pi equals A root 3, B 1 by root 3, C minus root 3, D minus 1 by root 3. So therefore we have limit of x tends to pi by 6, apply L'Hopital's rule, giving us 3 cos x plus root 3 sin x upon 6. Now we can apply the limit of x tends to pi by 6 and replace the value of x as pi by 6, giving us 3 into root 3 by 2 plus root 3 by 2 upon 6, that is 1 by root 3, which is option B. Limit of x tends to 0, 4 sin square plus 2x cos x upon 3x plus tan 3x equals A 2 by 7, B 11 by 3, C 13 by 7 or D 1 by 3. So therefore we can write the numerator as limit of x tends to 0, 4 into sin x by x into sin x plus 2 limit of x tends to 0, x cos x by x upon, and the denominator limit of 3x by x plus limit of tan 3x by x, which now we can apply the limit of x tends to 0, giving us 1 by 3. Limit of x tends to pi by 6, 2 sin square x plus sin x minus 1 upon 2 sin square x minus 3 sin x plus 1 equals A 3, B minus 3, C 6 or D 0. So therefore we can write the equation as limit of x tends to pi by 6, 2 sin x minus 1 sin of x plus 1 upon 2 sin of x minus 1 into sin of x minus 1. That gives us limit of x tends to pi by 6 sin x plus 1 upon sin x minus 1. Now we can apply the limit of x tends to pi by 6, giving us minus 3, which is option B. Limit of x tends to 0, 1 minus cos 2x upon cos 2x minus cos 8x equals A 1 by 17, B 1 by 5, C 1 by 15, D 1 by 7. So we can write this equation as limit of x tends to 0 to sine square x upon 2 sine, take this as 2x plus 8x by 2 and sine 8x minus 2x by 2. This way we can solve it in a much easier and faster method, giving us limit of x tends to 0 sine square x by sine 5x into sine 3x. Now we can apply the limit, giving us 1 by 15, which is option C. The value of limit x tends to 0 tan of pi by 4 plus x raised to 1 by x is a e b e square c 2 by e d 1 by e square. So therefore we can write this equation as limit of x tends to 0 1 plus tan x upon 1 minus tan x raised to 1 by x. That gives us e raised to limit of x tends to 0 to tan x by 1 minus tan x into 1 by x, which is e raised to limit of x tends to 0 into 2 upon 1 minus tan x into 1 by x. Now this is 2, therefore the answer is e raised to 2, which is option B. Limit of x tends to pi 1 plus cos cube x by x minus pi the whole square is equal to a 1 by 3, b 1 by 2, c 3 by 2 or d 1. So therefore we have limit of x tends to pi 1 plus cos cube pi plus h upon h square. Here we've replaced these terms by h, giving us this will now be h tends to 0. So we have limit of h tends to 0 1 plus cos cube of h upon h square, which is limit of h tends to 0 1 minus cos h upon h square, which is this will be also multiplied with limit of h tends to 0 1 plus cos h plus cos square h, which now we can apply the limit of h tends to 0, giving us 1 by 2 into 3, which is 3 by 2, option C. If f of x is equal to sin x by x cube by 2x into cos x by x square upon 1 and tan x by x by 1, it is equal to a 1 by 3, b 1 by 2, c 3 by 2 or d 1. So therefore we can write f of x as x into x minus 1 sin x minus x cube minus x square cos x minus x cube tan x, which is equal to x square sin x minus x cube cos x minus x cube tan x plus 2x square cos x minus x sin x. Hence the limit x tends to 0 f of x by x square is equal to limit of x tends to 0 sin x minus x cos x minus x tan x plus 2 cos x minus sin x by x, which is 0 minus 0 minus 0 plus 2 minus 1, and that is equal to 1, which is option D. Limit of x tends to minus 2 sin inverse of x plus 2 upon x square plus 2x is equal to a 0, b infinity, c minus 1 by 2, or d 2. So we use L'Hopital's rule, giving us limit of x tends to minus 2, 1 by root of 1 minus x plus 2 the whole square upon 2x plus 2. Now we can apply the limit of x tends to minus 2, giving us 1 upon minus 4 plus 2, which is equal to minus 1 by 2. Option C. The value of limit x tends to 0 sin x by x raised to 1 by x square is a e raised to 1 by 3, b e raised to 1 by 5, c e raised to 1 by 6, or d e raised to 1 by 2. So what we do first is we'll expand the sin x term, giving us limit of x tends to 0 x minus x cube by 3 factorial plus x raised to 5 by 5 factorial, so on, raised to 1 by x square upon x. Now we write limit of x tends to 0 1 minus x square by 3 factorial plus x raised to 4 by 5 factorial minus so and so, dividing each term by x raised to 1 by x square. Now this gives us e raised to limit of x tends to 0 1 by x square, take that common, into minus x square by 3 factorial plus x raised to 4 by 5 factorial, minus, and so on. That is nothing but e raised to minus 1 by 3 factorial, that is e raised to minus 1 by 6, which is option C. There is a correction in the question, both these terms have minus signs. The value of limit x tends to 0 a raised to x plus b raised to x plus c raised to x by 3 raised to 1 by x is abc, b abc raised to 1 by 3, c 1 by 3 into abc, or d just 1 by 3. So what we do is we could write it as limit of x tends to 0 1 plus a raised to x plus b raised to x plus c raised to x upon 3 minus 3. Now this raised to the 1 by x, giving us limit of x tends to 0 1 plus ax minus 1 plus b raised to x minus 1 plus c raised to x minus 1 by 3 raised to 1 by x. Now that gives us e raised to limit of x tends to 0 a raised to x minus 1 upon 3x plus b raised to x minus 1 by 3x plus e raised to x minus 1 upon 3x, that is e raised to log of abc raised to 1 by 3, which is abc raised to 1 by 3. The limit of theta tends to 0 e raised to theta plus e raised to minus theta minus 2 upon sine square theta is equal to a 1 b 0 c minus 1, or d root of minus 2. So we can write the term as limit of theta tends to 0 e raised to theta plus 1 upon e raised to theta minus 2 upon sine square theta. Now that is limit of e raised to theta minus 1 the whole square upon theta square upon e raised to theta into sine square theta upon theta square, which is equal to log of e the whole square upon 1, which is equal to 1 on applying the limit theta tends to 0. Limit of x tends to 0, 2 log 1 plus x minus 1 minus log of 1 plus 2x upon x square is equal to a0, b1, c minus 1 or d2. So we can write this as limit of x tends to 0, log of 1 plus x the whole square upon 1 plus 2x upon x square. So this could be written as limit of x tends to 0, log of 1 plus x square upon 1 plus 2x upon x square upon 1 plus 2x into 1 by 1 plus 2x. From this we get, on applying the limit of x tends to 0, we get the answer 1, which is option B. The limit of x tends to 0, a raised to 3x minus a raised to 2x minus a raised to x plus 1 upon x square is equal to a root 2 log 2a square, b root 2 log a, c 2 log a the whole square, d 2 log a cube. So we can write this as limit of a raised to 2x into a raised to x minus a raised to 2x minus a raised to x plus 1 upon x square, and we can group it as x limit of x tends to 0, a raised to 2x minus 1 into a raised to x minus 1 upon x square. Now that is log a square into log a, and we can apply the limits x tends to 0 to get this, which gives us 2 log a square, which is option C. The value of limit x tends to 1 log x by sine pi x is a 1 by pi, b minus pi, c pi or d minus 1 by pi. So first for this we can write limit of x tends to 1 log of 1 plus x minus 1 upon sine of pi minus pi x, which gives us limit of x tends to 1 log of 1 plus x minus 1 upon sine pi 1 minus x, giving us limit of x tends to 1 log 1 plus x minus 1 upon x minus 1 into x minus 1 upon sine pi of 1 minus x. That gives us minus 1 by pi, limit of x tends to 1 log 1 plus x minus 1 upon x minus 1 into pi of 1 minus x upon sine pi 1 minus x. We can apply the limit of x tends to 1 now to get minus 1 by pi, which is option D. The limit of x tends to 0, 12 raised to x minus 3 raised to x minus 4 raised to x plus 1 upon x sin x is equal to a log of root 3 into log 4, b log 4 into log 3, c log 2 into log 3, d log root 1 into log 2. So therefore we could write it as limit of x tends to 0, 4 into 3 raised to x minus 3 raised to x minus 4 raised to x plus 1 upon x sine x. That gives us limit of x tends to 0 4x into 3 raised to x minus 1 minus 1 3 raised to x minus 1 upon x sine x. That gives us limit of x tends to 0 4 raised to x minus 1 by x 3 raised to x minus 1 by x upon sine of x by x, which gives us, on applying the limit of x tends to 0, log of 4 into log 3, which is option B. Limit of x tends to 0 e raised to 1 by x minus 1 upon e raised to 1 by x plus 1 equals a0 b1 c minus 1 d does not exist. So therefore we could write f of x equals e raised to 1 by x minus 1 upon e raised to 1 by x plus 1. Then we could say limit of x tends to 0 on the positive, f of x equals limit of h tends to 0 e raised to 1 by h minus 1 upon e raised to 1 by h plus 1, which gives us limit of h tends to 0 e raised to 1 by h into 1 minus 1 by e raised to 1 by h upon e raised to 1 by h into 1 plus 1 by e raised to 1 by h. Now we apply the limit of x tends to 0 is equal to 1. Similarly, for limit of x tends to 0 on the minus, f of x equals to minus 1. So we could say from this, hence the limit does not exist, which is D. Limit of n tends to infinity, summation of n numbers upon summation of all the odd numbers equals a1 b 3 by 2 c 1 by 2 or d 2. So therefore we could write it as limit of n tends to infinity n into n plus 1, that is summation of n numbers upon 2 into n square, giving us limit of n tends to infinity n into n plus 1 upon 2n square. Therefore we could write limit of n tends to infinity n square plus n upon 2n square. Now applying the limits of n tends to infinity, we get it as 1 by 2, which is option C. Value of limit of n tends to infinity 1 into 2 plus 2 into 3 plus 3 into 4 so on till n into n plus 1 is by n by 3 is a 1 b minus 1 c 1 by 3 or d 3. So we can write this as limit of n tends to infinity summation of r is equal to 1 till n r into r plus 1 upon n cube, which gives us limit of n tends to infinity summation of r is equal to 1 to n r square plus summation of r is equal to 1 up to n of r upon n cube. So this gives us limit of n tends to infinity n into n plus 1 to n plus 1 by 6 plus n into n plus 1 by 2 upon n cube. That is limit of n tends to infinity n into n plus 1 n plus 2 upon 3n cube. Now we apply the limits of n tends to infinity, giving us 1 by 3, which is option C. Limit of x tends to infinity of x plus 6 upon x plus 1 raised to x plus 4 is a0 b1 c e raised to 4 or d e raised to 5. So therefore we could write this as limit of x tends to infinity x plus 1 plus 5 upon x plus 1 raised to x plus 4. Now that gives us limit of x tends to infinity 1 plus 5 by x plus 1 raised to x plus 4, and we could write the 4 as plus 1 plus 3. So we have limit of x tends to infinity 1 plus 5 by x plus 1 raised to x plus 1 plus or into 1 plus 5 by x plus 1 raised to 3. Now that gives us e raised to 5 into 1 cube, as the limit of x tends to infinity into 5 by x plus 1 equals 0. So both these terms would get cancelled out. And on applying limits of x tends to infinity, so that gives us e raised to 5, which is option D. Limit of n tends to infinity 2 by 3 plus 2 by 3 square plus 2 by 3 cube plus so on till 2 by 3 raised to n is equal to a 1 by 2 b 2 c 1 d 3. So therefore we could write this as limit of n tends to infinity 2 by 3 1 minus 2 by 3 raised to n upon 1 minus 2 by 3. That gives us limit of n tends to infinity 2 into 1 minus 2 by 3 raised to n. And now we can apply the limit of n tends to infinity, giving us 2, which is option B. If f of x is equal to x minus sin x upon x plus cos square x, then limit of x tends to infinity of f of x is equal to a0, b infinity, c1, d none of these. So what we could do is, we have limit of x tends to infinity of f of x, which is limit of x tends to infinity root of x minus sin x by x plus cos square x. We could write this as limit of x tends to infinity root of 1 minus sin x by x upon 1 plus cos square x by x. Now we can apply the limit of x tends to infinity, cancelling out the terms. We are left with root of 1 by 1, which is 1, option C. Limit of n tends to infinity of 1 upon n cube plus 1 plus 4 upon n cube plus 1 and all the square roots upon n cube plus 1 up to n raised to n square n raised to 2 by n cube plus 1 equals a1, b 2 by 3, c 1 by 3 or d 0. So we could write this as limit of n tends to infinity 1 square plus 2 square plus 3 square and so on to n square upon 1 plus n cube. Limit of n tends to infinity summation of n square upon 1 plus n cube, which equals limit of n tends to infinity 1 by 6 1 plus 1 by n 2 plus 1 by n upon 1 by n cube plus 1. We get this by using the formula of summation of n square. Now we can apply the limit of n tends to infinity, giving us 1 by 6 into 1 into 2, that is 1 by 3, option C. The value of limit 3x minus 4 upon 3x plus 2 raised to x plus 1 by 3 is equal to e raised to minus 1 by 3, b e raised to minus 2 by 3, c e raised to minus 1 or d e raised to minus 2. So therefore we can write it as limit of x tends to infinity 3x plus 2 minus 6 upon 3x plus 2. Numerator in terms of the denominator, x plus 1 by 6, giving us limit of x tends to infinity 1 minus 6 by 3x plus 2 raised to 3x plus 2 by minus 6. Now this raised to minus 6 by 3x plus 2 into x plus 1 by 3. That adjusts back to x plus 1 by 6, giving us limit of x tends to infinity e raised to minus 2 of x plus 1 upon 3x plus 2. We can apply the limit of x tends to infinity, giving us e raised to minus 2 by 3, as this limit is equal to minus 2 by 3, which is option B. Limit of x tends to infinity root of x plus root of x plus root of x minus root x is equal to a0 b1 by 2 c log 2 or d e raised to 4. So we could write the equation as x plus root of x plus root x minus x upon root of x plus root of x plus root of x plus root x by multiplying and dividing it by its conjugate, giving us limit of x tends to infinity root of x plus root x upon root of x plus root of x plus root x plus root x, which is equal to limit of x tends to infinity root of 1 plus x raised to minus 1 by 2 upon root of 1 plus root of x raised to minus 1 plus x raised to minus 3 by 2 plus 1. Now we can apply the limit of x tends to infinity, giving us 1 by 2, which is option B. Limit of x tends to a root of a plus 2x minus root 3x upon root 3a plus x minus 2 root x equals a 1 by root 3, b 2 by 3 root 3, c 2 by root 3 or d 2 by 3. So first we could write it as limit of x tends to a root of a plus 2x minus root 3x upon root of 3a plus x minus 2 root x, and multiply and divide by the conjugate, a plus 2x plus root 3x upon a plus 2x plus root 3x into again a conjugate 3a plus x plus 2 root x upon root 3a plus x plus 2 root x. That gives limit of x tends to a 3a plus x plus 2 root x upon 3 into root of a plus 2x plus root 3x. And now we can apply the limit of x tends to a, replace a by x by a, giving us 2 by 3 root 3, which is option B. Limit of x tends to 0, 1 minus cos mx upon 1 minus cos nx is equal to a m by n, b n by m, c m square by n square, d n square by m square. So we have limit of x tends to 0 to sine square mx by 2 upon 2 sine square nx by 2. We could write this as limit of x tends to 0 sine of mx by 2 the whole square upon mx by 2 the whole square into m square x square upon 4 into 1 by sine of nx by 2 upon nx by 2 the whole square into 4 by n square x square. This gives us m square by n square into 1 on applying the limit of x tends to 0 here, which is m square by n square, option C. Limit of x tends to 0 tan x minus sin x upon x cube equals a 1 by 2, b minus 1 by 2, c 2 by 3, or d none of these. So first we could write limit of x tends to 0 of sin x minus sin x cos x upon x cube cos x. We get this by writing tan x in terms of sin and cos, giving us limit of x tends to 0 sin x 2 sin square x by 2 upon x cube cos x. We get this by taking sin x common, and we have 1 minus cos x. 1 minus cos x is equal to 2 sin square x by 2. So now we could write limit of x tends to 0 sine of x by 2, 2 by cos x sine square x by 2 upon x by 2 the whole square into 1 by 4. Now when we apply the limit of x tends to 0 into this part, we get the answer 1 by 2, which is option A. Limit of x tends to 1, 1 minus root of x upon cos inverse of x the whole square equals a 1, b 1 by 2, c 1 by 4, or d none of these. So first we could put cos inverse of x as y, and when x tends to 1, y tends to 0. So therefore the limit of x tends to 1, 1 minus root x upon cos inverse of x the whole square could be written as limit of y tends to 0, 1 minus root of cos y upon y square. Now rationalizing it, we get limit of y tends to 0, 1 minus cos y upon 1 plus root of cos y, giving us limit of y tends to 0, 1 minus cos y upon y square into limit of y tends to 0, 1 upon 1 plus root of cos y. Now we can apply the limit of y tends to 0 to these terms, giving us 1 by 2 into 1 by 2, which is equal to 1 by 4. That is option C. Limit of x tends to infinity, root of x square plus 1 minus root of x square plus 1 equals a minus 1 by 2, b 1 by 2, c 1, or d minus 1. So therefore we can write limit of x tends to infinity, x square plus x plus 1 minus x square minus 1 upon root of x square plus x plus 1 plus root of x square plus 1. That is by taking the conjugate and multiplying and dividing it. Therefore we get limit of x tends to infinity 1 upon root of 1 plus 1 by x plus 1 by x square plus root of 1 plus 1 by x square. Now we can apply the limit of x tends to infinity, and all the 1 by x terms gets cancelled out, and we are left with 1 by 1 plus 1, which is equal to 1 by 2. That is option B. Limit of x tends to 0, x into e raised to x minus log of 1 plus x by x square equals a 2 by 3, b 1 by 3, c 1 by 2, or d 3 by 2. So therefore by applying L'Hopital's rule, we get y that we state for the limit of x tends to 0, e raised to x plus x into e raised to x minus 1 upon 1 plus x upon 2x, that is the derivative. This also is in 0 by 0 form, and therefore we get limit of x tends to 0, 1 by 2 e raised to x plus e raised to x plus x into e raised to x plus 1 by 1 plus x square. That is equal to limit of x tends to 0, 1 by 2 into 3. and applying the limit of x tends to 0, there is no term. These constant factors come out, giving us only 3 by 2, which is option D. Limit of x tends to pi by 2, a raised to cot x minus a raised to cos x upon cot x minus cos x equals a log a, b log 2, c log a, or d log x. By using L'Hopital's rule, therefore we get limit of x tends to pi by 2, limit a raised to cos x. Sorry, we don't use L'Hopital's rule, we just take a raised to cos x common for the numerator, giving us a raised to cot x minus cos x minus 1 upon a raised to cot x minus cos x. Now this gives us a raised to cos of pi by 2, limit of x tends to pi by 2 into a raised to cot x minus cos x minus 1 upon cot x minus cos x. Now we can apply the limit of x tends to pi by 2, that gives us 1 into log of a, which is log a, or option A. Limit of x tends to 0, 4 raised to x minus 9 raised to x by x into 4 raised to x plus 9 raised to x equals a log 2 by 3, b 1 by 2 log 3 by 2, c 1 by 2 log 2 by 3, or d log 3 by 2. So therefore it's in 0 by 0 form, and we use L'Hopital's rule to get limit of x tends to 0, 4 raised to x log 4 minus 9 raised to x log 9 upon 4 raised to x plus 9 raised to x plus x common 4 raised to x log 4 plus 9 raised to x log 9. Therefore, simplifying it, we get log 4 minus log 9 upon 2. That is log of 2 by 3 the whole square by 2. That is log of 2 by 3. It is easier to solve it this way, as most of the terms get eliminated by applying the limit of x tends to 0, giving us this part. Now this is option A. Limit of n tends to infinity of 1 by 2 plus 1 by 2 square plus 1 by 2 cube up to 1 by 2 raised to n equals a2, b minus 1, c 1, or d 3. So therefore we could write this as limit of n tends to infinity 1 by 2 into 1 minus 1 by 2 raised to n divided by 1 minus 1 by 2 in the denominator. Now this gives us limit of n tends to infinity 1 minus 1 by 2 raised to n. We can apply the limit of n tends to infinity, giving us 1, which is option C. Limit of x tends to 0, x cos x minus sin x upon x square sin x equals a 1 by 3, b minus 1 by 3, c 1, or d none of these. So what we do first is we write it as limit of x tends to 0 minus sin x in the numerator upon 2 sin x plus x cos x. This is by L'Hopital's rule. Now again we use it to get limit of x tends to 0 minus cos x, the derivative, and upon 3 cos x minus x sin x. Using the limit of x tends to 0, we get minus 1 by 3, which is option B. Limit of x tends to pi by 4 root 2 cos x minus 1 upon cot x minus 1 equals a 1 by root 2, b 1 by 2, c 1 by 2 root 2, or d 1. So first we can write the term as limit of x tends to pi by 4 sin x into 1 plus cot x. upon root 2 plus sec x. This we get by writing everything in terms of sin x, and we could simplify it further. Now we can apply the limit of x tends to pi by 4, giving us 1 by root 2 into 2 upon root 2 plus root 2, that is 1 by 2, or option B. Limit of x tends to 0 root of 1 by 2 into 1 minus cos 2x by x equals a1, b minus 1, c 0, or d none of these. So first we could write this as limit of x tends to 0 of modulus sin x by x degrees. So the limit of x tends to 0 in the positive, sin x by x equals 1, and on the negative side equals minus 1. Hence the limit does not exist. So therefore D. The limit of x tends to 0 sin x plus log of 1 minus x upon x square equals a0, b 1 by 2, c minus 1 by 2, d none of these. So first we apply the L'Hopital's rule on this, giving us limit of x tends to 0 cos x minus 1 by 1 minus x upon 2x, giving us limit of x tends to 0 minus sin x minus 1 by 1 minus x the whole square by 2. Then we apply the limit x tends to 0, giving us minus 1 by 2, which is option C. Limit of x tends to 0 a raised to x minus b raised to x upon x minus 1 equals log of b by a, log a by b, c a by b, or d a. So therefore we write limit of x tends to 0, and we could write this as a raised to x minus 1 upon x minus limit of x tends to 0 b raised to x minus 1 by x. Now that could be written as log a minus log b, and that could be written as log of a by b, which is option B. Limit of x tends to 0 log of cos x by x square equals a0, b1, c1 by 2, or d minus 1 by 2. Now applying L'Hopital's rule, we get limit of x tends to 0 log of cos x by x square. We apply L'Hopital's rule on this, giving us limit of x tends to 0 minus tan x by 2x. Now again we use the same, giving us x tends to 0 minus sec square x by 2, and applying the limit of x tends to 0 we get minus 1 by 2, which is option D. Limit of x tends to 0 log of 1 plus x to the base e divided by 3 raised to x minus 1 equals a log 3 to the base e, b 0, c 1, or d log e to the base 3. So first, now we know it is in 0 by 0 form, and therefore using L'Hopital's rule we get limit of x tends to 0 1 by 1 plus x divided by log 3 to the base e, which is 1 by log of 3 to the base e, on applying the limit of x tends to 0. Now if we want to take it in the numerator, that gives us log of e to the base 3, which is option D. Limit of x tends to 0 e raised to x minus e raised to sin x upon x minus sin x equals a minus 1, b 0, c 1, or d none of these. So it's in 0 by 0 form, and we can use L'Hopital's rule, giving us limit of x tends to 0 e raised to sin x into e raised to x minus sin x minus 1 upon x minus sine x. Now that gives us limit of x tends to 0 e raised to x minus sine x minus 1 upon x minus sine x. Now when we apply the limit of x tends to 0 in these three terms, we are left with 1, which is option C. Limit the value of limit x tends to 0 2 by x log of 1 plus x is equal to a e b e square c 1 by 2 or d 2. So we could write this as limit of x tends to 0 2 into log of 1 plus x raised to 1 by x, which gives us limit of x tends to 0 to log of e to the base e. Now log e to the base e is 1, and when we apply limits x tends to 0, we get 1 into 2, which is 2. That is option D. Limit of x tends to infinity 1 plus 1 by mx raised to x equals a e raised to 1 by m, b e raised to minus 1 by m, c e raised to m, or d m raised to e. Now we could write this as limit of x. We could write this as limit of x tends to infinity 1 plus 1 by mx raised to mx into 1 by m. Now we apply the limit of x tends to infinity, giving us e raised to 1 by n, which is option A. Limit of n tends to infinity n by n plus y raised to n equals a0 b1 c1 by y or d e raised to minus y. So therefore we can write limit of n tends to infinity 1 upon 1 plus y by n raised to n, giving us limit of n tends to infinity 1 plus y by n raised to minus n. That gives us limit of n tends to infinity 1 plus y by n raised to n raised to minus 1. Now we can apply the limit of n tends to infinity, giving us e raised to minus y, which is option D. Limit of x tends to infinity 2x minus 1 raised to 40 into 4x minus 1 raised to 5 upon 2x plus 3 raised to 45 equals a 16, b 24, c 32 and d 8. So therefore we could write this as limit of x tends to infinity 2 of 1 plus x raised to 40 into 4 minus 1 by x raised to 5 upon 2 plus 3 by x raised to 45. So on applying the limit of x tends to infinity on these three terms, we get 2 raised to 40 into 4 raised to 5 upon 2 raised to 45. So we know this terms can cancel out on each other, leaving us with 2 raised to 5, that is 32. Option C.